Hi, we're back with a new section of this video course, Managing User Logins. In the previous section we understood SELinux decisions and logging. In this section we'll define users that have sufficient rights to do their jobs, ranging from regular users with strict SELinux protections to fully privileged administrative users with few SELinux protections. Then we'll learn to create and assign categories and sensitivities. We'll also see how to assign roles to users and use various tools to switch roles. Finally, we'll end this section by learning how SELinux integrates with the Linux authentication process. Let's move on to the first video of this section that deals with user-oriented SELinux contexts. In this video, we'll first understand domain complexity, and then learn about querying for unconfined domains. When we log into an SELinux-enabled system, we're assigned a default context to work in. This context contains an SELinux user, an SELinux role, a domain, and optionally a sensitivity range. Once logged into a system, our user will run inside a certain context. This user context defines the rights and privileges that we, as a user, have on the system. The command to obtain current user information, ID, also supports SELinux context information. Let me show you this. On SELinux systems with a targeted policy type, chances are very high that all the users are logged in as unconfined U, which is the first part of the context. On more restricted systems, the user can be user U, which are regular restricted users, staff U, which are operators, sysadm U, or the system administrators, or any of the other SELinux user types. The SELinux user defines the roles that the user can switch to. SELinux roles define the application domains that the user can use. By default, a fixed number of SELinux users are available on the system, but administrators can create additional SELinux users. It's also the administrator's task to assign Linux logins to SELinux users. SELinux roles, on the other hand, cannot be created through administrative commands. For this, the SELinux policy needs to be enhanced with additional rules that create the role. To view the currently available roles, use SEInfo. Let's type the command SEInfo --role and press enter. So these are the current roles. Now, before looking at SELinux users and roles, let's look at the various complexity levels that policies can reflect, since they will direct our choice of the right SELinux user and role later on. For instance, they will guide us in differentiating between a coarse-grained user, such as sysadm-u, and a functionally oriented user, such as dbadm-u. Now let's move ahead for understanding domain complexity. SELinux is able to provide full system confinement. Each and every application runs in its own restricted environment that it cannot break out of. But that requires fine-grained policies that are developed as quickly as new releases of all the applications that they confine. Here's the diagram which shows this relation between policies, the domain scope towards multiple processes, and the development effort. As an example, postfix_cleanup_t is shown as a very fine-grained policy domain, whereas the unconfined t domain is shown in the example as a very broad, almost unlimited access domain. Policy complexity can be roughly categorized into these types. First one is fine-grained policy, with separate domains for individual applications and commands. Next, policy on application level. The third one is category-wide policy, which is reusable for multiple applications implementing similar functionality. And the last one is coarse-grained policy sets, including unconfined system access. Let's discuss policy complexity in depth. So, we take the first one, which is fine-grained policies. These policies have the advantage that they really attempt to restrict applications as much as possible. And through that, roles developed with users and administrators in mind become fine-grained as well. The disadvantage of such policies is that they are hard to maintain, requiring frequent updates as the application itself evolves. Next comes application-level policies. These use a single domain for an application, regardless of its subcomponents. This balances the requirement for application confinement versus the maintainability of the application. Such application-level policies are the most common in most distribution policies. The third, category-wide policies. These policies use a single domain definition for a set of applications that implement the same functionality. This is popular for services that act very similarly, and whose user role definitions can be described without really thinking about the specific application. A popular example of a category-wide policy is the policy for web servers. And the last one, coarse-grained policies. These policies are used for applications or services whose behavior is very hard to define. End-user domains are a good example of this, as is the unconfined domain, which puts almost no restrictions on what a domain can do. Let's look into querying for unconfined domains. So, the freedom in policy complexity results in different policy models being implemented and supported by different Linux distributions. RHEL, for instance, focuses its attention on the targeted policy store, where network-facing services are confined but user activities are generally not. This is handled by assigning the unconfined U SELinux user, unconfined R SELinux role, and unconfined T SELinux type to the end users. Moving on from the user domains, we also have unconfined process domains for daemons and other applications. Some of these run in the unconfined T domain as well, but most of them run in their own domain even though they are still unconfined. To find out whether a domain is unconfined, we can query the SELinux policy to show us those domains that have an SELinux attribute associated with unconfined domains. SELinux attributes enable us to group multiple SELinux types and assign permissions to them. A common unconfined attribute type is the unconfined_domain_type attribute. We can query which SELinux types have this attribute assigned through the SEInfo tool. So let's use this command. SEInfo-a unconfined_domain_type-x and click enter. Here's a list of the SELinux types. Superb. Administrators cannot switch individual unconfined domains to confined ones. In this video we explored about user-oriented SELinux contexts.